Thank you, Luke. So as he said, I'm the industry manager for mobility and transportation here at Autodesk. So I work really closely with a lot of the teams across the organization. Been here about 5 years, but prior to coming into the tech industry, I spent about 12 years in industry. So a number of different roles from sort of right at the beginning of the process in concept development all the way through to getting my hands dirty on the shop floor, really. So enables me to hopefully have some good conversations with people like yourselves on the call here today, and supporting our customers in the future. I'll hand over to Tua to introduce himself.
Hello and good morning if you're in the west coast of US. So my name is Tua Beijer. I'm co-founder and CTO of Swedish startup Stilride. We have a way of shaping flat sheet metal, and we fold it. And the reason why we do that is because we want to have a free-forming process that doesn't include any heavy tooling or fixed tooling. And this is something I've always been very, very interested about doing, because my background is from industrial design. I'm a vehicle designer by trade and been working with cars and motorcycles for a very long time. And I've seen the struggle on how to shape and the cost that's involved in shaping metal. So this is why we do, this is why we started up Stilride. So yeah, thanks for being here, by the way.
Perfect. So I think I can go ahead and share my screen, and we'll get started with the presentation. Just make sure I shared sound. Cool. All right, great stuff. So, yeah, I've already introduced myself. So, effectively, there's going to be three main things that we're going to talk about today. Really about, what are we hearing from the industry, what challenges we help solve, and then supporting, what we are solving is some proof points from our customers. And obviously, we've got Tua here today as well. So he's going to expand on what he sees on the industry and also some of the work that he's also done with ourselves over the past year or so. Before we dig into the meat of the presentation, just want to show you a quick video just to set the scene in terms of where Autodesk operates within the design and manufacturing space. So it's just about 1.5 minutes long, so I'll leave you with that. Cool. So yeah, we'll go through some of what you saw in the video a little later on in terms of the different life cycle stages that you might have seen there. But before we get to that, I just want to give sort of an overview in terms of the sector as we see it. So, the world's continuously changed around us for the past few years. There's a whole geopolitical landscape. There's global health and sustainability, which is on everyone's mind. So in industry, there's trends around AI, data, and security that continue to dominate in everything that we're doing. And it feels like, when we've evolved from one disruption, there's just something else that makes us rethink everything that we've been doing. So from all of this, micromobility continues to, as a sector, continue to build on some of the disruptions that have come in previous years. And we just see that there's three big forces at work. The first one around consumer, second around regulations, and the third around technology. So for consumers, we know that 30% of people plan to leverage micromobility this decade. 40% of those open to replacing private vehicles with other modes of transport, and 70% of these open to sharing with other travelers. With regulations, they continue to shape the requirements and constraints that the sector is working within. So things like the Paris Agreement, United Nations Sustainability Goals, etc. And finally, technology plays a huge role, so enabling the sector to grow and develop, and hence it's an area where Autodesk is involved to support with digital transformation, no matter where our customers are within their journey effectively. So for Autodesk, micromobility makes up one of the many sectors in the broader mobility industry that we support. We primarily support from a vehicular perspective, but also support the broader supply chain, so whether they're battery manufacturers, suppliers, and also infrastructure. But what it does for us as a company, it gives us that opportunity to learn and then share best practices and either take them on board or just completely ignore them, because we understand that each of these different sectors operates in sometimes slightly different ways. So what makes the micromobility sector so exciting and interesting to be part of for us is that there's just so many different products, applications of technologies, and there's a real customer focus effort during that whole product development phase, which we'll cover shortly. And for us, it's, the world is taking sustainability seriously, as, we continue to average a $3.4 trillion investment every year. And because we do work with a number of different organizations, we hear about large corporations investing in sustainability, micromobility fleets. And then you also get, smaller companies who are, looking for funding, have got grants for growth and expansion, and hence why digital transformation plays a role in either one of those different scenarios. And as I alluded to, I mean, the beauty is that the industry has a number of different players within it. So we appreciate that as an organization, that, you've got new entrants who are starting out their journey. They need to accelerate development due to agile operations, and thinking in new ways in many cases, pushing the boundary of what's possible today. Then there's those customers that we work with, who have been producing product for a number of years, but have recently diversified into something new or additional for micromobility offerings. And they often need to transform from something that they've been doing very typically for a very long time, to something that they need to get to market fast and that they can be competitive on cost. And in some cases, you get those companies who have literally just, torn up the catalog of what they've been doing before and said, right, we're just going to do something new. But again, in all these different cases, digital transformation has a role to play. So many of you will probably be familiar with a life cycle similar to this. So one which has, the development or concept phase within it, the engineering phase, manufacturing, scaling, and then managing all of that. You could almost replace the words in the circle for something similar. But as such, there's a number of different challenges that come when you're trying to develop a product across these different life cycle stages. So, in the early phases, in the concept development stage, it's really trying to create a product that, meets the intent. What's the goal or the ambition of the organization? What are they trying to work towards? And how can they work collaboratively with others within the organization? Then in the engineer phase, it's about actually, making that concept or design into reality and meeting or trading off some key attributes to get the best possible product out the door. And then manufacturing is obviously turning that design and engineered product physically into reality. So developing the right processes, facilities, and ensuring that they meet the time, cost, and quality targets as set out by the organization. And scaling in many cases, with conversations that we've had over a number of years, is one of the most challenging phases. So going into new markets with new regulations, ensuring that your facilities and factories can, be scaled up, also while making sure that, you've got a resilient supply chain, you can rely on your suppliers to deliver on time and to quality again, and that people can keep up along the way, essentially. And our customers tell us that managing all of this is a continuous cycle. So even when it goes out into the field, but they have to leverage data, manage risks, whilst also constantly evolving in what is an ever-changing micromobility industry. So this slide we call the chaos slide, because it explains some of the chaos that we see when we talk to some manufacturing customers. But most of the time they tell us that they're stretched to breaking point, managing these broken processes, multiple data formats, there's manual systems, they don't talk to one another, there's a mix of analog and digital information. So effectively, this paints the picture, but you could take that further and say, well, actually, I do work with suppliers who have equally got their own mess. So if you work with, a few suppliers, then you've got effectively what could be a very messy and chaotic sort of scenario. So effectively, what we're trying to support with and provide solutions for is something that can help reduce the chaos and serve the industry across design and manufacturing. Hence why I showed the 5 different product development lifecycle stages, and hence why I gave you that 1.5-minute video at the beginning, just to give you a bit of a glimpse. But let's just take a bit of a deeper dive into each one of those now, and give you like a real life example of what's happened within that phase. So within develop, so we worked with a company called Simple Energy. They used Autodesk tools, the ones similar to what Tua will talk about later on, that will help them to develop their concepts and designs. And they basically did all their design and development around the key constraints, enabling the other teams to review and assess the impact directly. So effectively, what they had is a suite of tools which enabled them to collaborate globally on whatever somebody might be drawing, but also effectively be able to visualize that product and understand what it might look like when it comes to market effectively. And then during the engineer phase, so right at the beginning of the presentation, I talked about, legislation and requirements that continuously change. Minda were able to use some CFD tools that are within the industry that enable them to, quickly mock up what some changes might be in terms of their electrical systems. And what it did for them really early is to simulate what might happen during the complete life cycle of that product, and then they were effectively able to engineer in or out any specific attributes or requirements that they had. In manufacturing, so when you're building, a product, obviously many of you know there's multiple parts and components that need, designing and then sourcing and then bringing in, assembling, quality checking, etc. What Pix Moving did is that they actually used a number of different manufacturing technologies to reduce the amount of parts on their vehicle, so much so that they reduced 90% fewer parts in their whole vehicle, which is frankly amazing. So they used a range of different manufacturing technologies, be it additive manufacturing or subtractive or a hybrid mix of the two, in order to bring to life their robo bus that you can see the image of on the left hand side there. Within scale, so I talked earlier about scaling, so this is primarily around factory, this part of it. But yeah, Porsche basically brought all their data together in what was a single integrated model, which enabled different functions who were supporting the build of their factory come together. So if you imagine if you're going to build a new factory, then you need an architect to draw it. You need engineers to understand structural loading, where are all my pipes going to go, electrical connections, etc. And then you need to build it, and then there comes the point of obviously operating the factory. So they were able to bring all the data together and also plan for a factory that had zero impact sustainability contributions. So they were net zero effectively for their new Taycan factory in Germany. From an infrastructure perspective, we're starting to work with a number of companies now, actually. But Wallbox is one specific example where they use the power of a platform on a cloud in order to keep their teams across the world talking to one another, and also making sure that they weren't sharing individual files with one another, which might mean that somebody's working on an outdated version. So it's effectively an area where they could all make sure that they were all singing off the same hymn sheet, if you like, to make sure that they could engineer and bring their product to market as fast as possible. Another example of infrastructure is we all understand, how important charging is and bringing that to life globally and making sure we've got infrastructure for it. Well, Audi used a different tool set from Autodesk portfolio, actually a completely different industry vertical, which is architecture, engineering, and construction, to apply prefabrication to their facilities, their charging facilities, and then bring them on site and put them together in less than 4 weeks, which would have typically taken a lot longer had it just all been done manually on site. And then the final stage is around manage. So again, another organization that we worked with in APAC, but with Gendermark, they were able to bring their key stakeholders both internally and externally together to achieve outcomes for productivity and cost. And they were able to do that because they managed all their data inputs in one place, and they could make timely and critical decisions effectively on what they needed to do to progress their product through. So that's just some examples around the different life cycle stages. I just wanted to touch a little bit on how this sort of comes to life, really. So at Autodesk, we've developed and are developing further a platform, and effectively the platform is made up of 3 industry clouds. So primarily the one that I've been talking about today is the Fusion Industry Cloud for design and manufacturing. But there's also the former Industry Cloud, which brings together architecture, engineering, and construction information. And then there's the Flow Industry Cloud, which is for our media and entertainment business. So effectively, all this data gets aggregated onto the industry clouds and then exists on an Autodesk data model. Now, this is something that's quite unique because effectively it enables those disciplines who own that data to share the relevant pieces of them with their stakeholders. So if you imagine the scenario I gave you previously about Porsche will obviously have a group of architects, contractors, engineers working within their own specific disciplines, but they don't always want to share heavy models with one another that somebody might not know how to use, or they might not know how to open effectively. So what we're doing is making sure that we can get the right data into the right people's hands at the right time, which effectively helps them with their decision making. And it all doesn't just exist on just leveraging Autodesk technology, because we know that that's not how the world works. So we appreciate that there's the ability to plug in different vendors or partners' data into the manufacturing data model, combined with our portfolio, in order to be able to share this data amongst teams and businesses. And then beneath that, you can see, obviously, you can build a whole number of APIs in there. You can plug in other pieces of partner data and software specific to whatever the customer might be doing. So just to wrap up from my side before we hand over to Tua, these are 5 big digital transformation capabilities that we support our customers with. Effectively, what I've talked about here today is like a whistle-stop tour of a little bit of detail in terms of what we might be able to sort of support customers with moving forward. And again, there's 5 capabilities here, but it doesn't always mean that somebody's going to need to do or want to do all 5. But it's just to make the point that, digital transformation can help you to meet a challenge that you might have within a specific area here, or plan for what you might be doing in the future. And like I said, it's you start where you think you would want to start, and move from there, really. So that concludes sort of my part of the presentation, really. But I'm going to be on the webinar for the rest of the time, obviously. But I'll now hand over to Tua. But before him and Luke go through a bit of a Q&A session, I just wanted to show you a short video that will introduce what they do and how they've been working with us. So I'll do that now.
So at Stilride, Alias is our weapon of choice in order to finalize our product. Stilride in Stockholm, probably known for the bike, Stilride 1. For us, it was very obvious from the very beginning, that we wanted to have an electrical bike because it makes sense. It's an urban bike. It'll do 120 kilometers. That's more than enough to cover your daily transport. When it comes to EVs, it's opened up the possibility for smaller brands to enter this vehicle market. I had an idea about folding sheet metal, but not in straight lines, but with curves. Going from flat sheet to the product, but make that as few steps as possible with the highest level of refinement. So Stilride is the brainchild of that, and the bike, which is our brand builder, but also proof of concept. And now we expand into other areas. So why curve folding? Normally, when you fold things over straight lines, you can see both sides of the fold, they're independent. The opposite thing happens when you curve fold. You create a system. When I fold this on one side of the curve, the other one side of the curve will actually follow. What we did there is that we used the curve folding itself to create the mechanical strength, and we managed to design the bikes with only 9 parts. The chassis we designed with our own software. This is nothing out there that can really handle curve folding. But then when it comes to the other traditional things like mastering Class A surfaces, we're very, very much concerned about the design and the appearance of our products. Alias is the weapon of choice.
Alias is a wonderful tool. It's so easy to work with. It's fast. It's so subtle. You can do anything with it. The handlebar is a really complex piece because it goes from a cylinder shape to a sort of a wing shape and then back to a cylinder shape. It also bends upwards and backwards and turns down again. So the analysis tools are extremely valuable. We use light tunnel, zebra, isophotes, the curvature plots everywhere to see if I could make the lines flow. It's like music. It has to flow. It has to have a harmony. I couldn't have made that without Alias. It has such control.
People might have heard of us through the bike, but that's not the end of the story. It's just the beginning. We want to open up possibilities to new designs for vast number of different kind of designs. It's just, the sky's the limit.
Very good. I'll just stop sharing.
Great, thank you so much. That was, first of all, amazing presentation, Rohit. Thank you for sharing some of that. I want to get back to it later on during the Q&A section. I hope people will bring some questions for Rohit about all the different topics he just laid out for us, including mass customization, using digital tooling to help kind of refine the design process, managing suppliers. These are all questions that I know our community cares a lot about, because our community consists of a lot of people like Tua, who are startups, manufacturers, companies that need to bring their first product to market, companies trying to figure out this whole interconnected global supply chain and how they fit into it. So I know that this is a great opportunity for people to ask questions of you and get your kind of veteran feedback. While people put together some questions and think of what they want to ask, I would love to chat more about Stilride. That video, I'm very glad we had a chance to watch, because I think you really do need to see and hear a little bit about the product, especially see the products before people can fully understand what you guys are doing. We were lucky to have Stilride on our podcast a couple years ago, and it was a very popular episode. Maybe just in a nutshell, could you give us a quick background on Stilride? I know the video did a little bit, but I guess I'm curious, when were you founded? Where are you founded? How big are you guys? What's your business model? Just to give us a little bit of context for the audience.
Yeah, right. Again, thank you for having me. Well, I try to be as brief as possible. Again, I mean, being an industrial designer and vehicle designer, I always, seen the struggle that customers have when they want to work with sheet metal. Right. So if you're not in the car industry, where you have the access to expensive tooling, etc., you're pretty much destined to use the traditional folding techniques that are straight folds, becomes, you cut, you fold, and you weld, or you rivet, and then on top of this, you put a design probably made out of vac formed plastic. So one can say that Stilride was born about to liberalize the use of sheet metal, and also take the sheet metal to different kind of to enable it to do other things than just be something that you fold over straight lines, or B, something that you need press tools to do. So we wanted to cherry pick, the abilities to freeform, but also have the possibility, the access also to fold it in for designers, that's not in the car industry mainly. So so the brainchild of that was the bike. I used my ideas, tried out very much trial and error with paper, cardboard models, etc., and so on, and also realizing there is not much out there that can support curve folding. So this is, of course, a very, very interesting area to enter. So I think that's in the mind of designers to explore, or engineers, or that we love to make things, and we love to see what's out there and around the corner. And so this was very much a trial and error thing, that exploring the possibilities of fold. And I would like to go back to, that just I showed you in the video, that you have over a straight line when you fold over a straight line, and when you fold over a curve, it's like open up a whole new world of possibilities, but also challenges. So make a long story short, being a fan of old scooters, motorcycles, but old scooters, I applied my ideas on a scooter I designed years back. It's actually, you can see it briefly in the video, and I wanted to see what it was possible to kind of mimic or get close to that design, and we did. And I say we because on the journey, I have my old friend Jonas Nyvang, who is an old friend of mine. He's also into design, but he's more on the marketing side of things. And after showing him some models, etc., on the initial chassis, he jumped on board. We got some governmental funding, and we managed to do what we were set to do, curve folding. And then we saw the attention the bike gave us, and then we could start our journey with Stilride.
It's interesting. From So the way something is manufactured determines so much about the product. This sort of folded metal approach, like if you could distill it down, what would you say are the main benefits to you as a business, and what would you say are the main benefits to a consumer or rider? What are, just to help me understand more as a bit of a layman here.
All right. So if we just break loose the manufacturing part of things, the fact that you can actually produce straight out from flat sheet metal using just the patterns giving you from the software we created and then fold it with very few parts. That's of course one benefit. The other one also being that we can the mechanical, this is called a compliant mechanism, and it creates a mechanical connection between the two surfaces. And when locking this into, I mean, this one will be locked in the system, especially if you make an enclosure, then you create a very, very strong structure. And for the rider, this is obvious when riding the bike, because you have a bike that is really, really strong and has a good chassis. And a good chassis creates, that's something that you can depend upon. It's something that you can rely upon. You could put good suspension parts, etc., and so on. So you will have a premium ride experience.
And from a service and maintenance point of view, how does it all, is that, you mentioned in the video that there's fewer components. I think you said there were 7 components of the chassis. Like, so does that make the service and maintenance more? I know that's a huge issue of micromobility, right? It is, once you have this cool new vehicle, how do you get it fixed? Who do you take it to? Is it easy to get repaired? Is it cheap to get repaired?
Yeah. So when it comes to service, if we just dig into that just shortly and briefly, we designed the bike to be very made for manufacturing. This means also that we can, deassemble it as well. So that's made like in modules pretty much. So it means that if you want to update your batteries or anything, those can be easily detached, and you can perform maintenance on them themselves. Then we also have a over-the-air update system like you have on your Tesla. And I think that's the whole thing, with micromobility, especially when it comes to electric vehicles, that you can perform such things, So
Yeah. Are there other examples of companies, either in automotive or other categories, utilizing a similar manufacturing technique to you guys?
No, I'd say there's, you can see curve folding has been, I mean, more on a decorative, like in furnitures, lamps, etc., and so on. I've seen it. We have it in textiles, like this. It's curve folded around your neck. So you also have it in some packaging. I've seen it in packaging as well, where they utilize that. And but it's also in nature, of course, which is the greatest inspiration of all. You can find it in nature, some insect wings, etc., and so on.
Okay, interesting. So, and maybe just a little bit more about the business itself. Just when were you guys founded? What's sort of in your business model for getting these products to market? How far are you in your go-to-market strategy? Maybe that would be good helpful context for the audience as well to have.
Yeah, I mean, we understood the power of design, and we knew that we have something new here, and if we want to show and tell the world about this technique, we knew that we had to reach out. If we just made a beam, and said like, hey, we have a very fantastic beam here, you have to see it, I think people wouldn't be that interested. But I think it's also important to use design in order to communicate and also attract interest, and because people react to it, and they have opinions, and they like it or they dislike it, or so it's a door opener for us. The bike is a door and opener for the technique. So now showing the bike gives us the opportunity to speak to other to other manufacturers, etc. And so we work a lot with the automotive industry, where there's a stress of decarbonize, and to make more sustainable products. So when we can tell them, you can do a trailer chassis, or that normally consists about 150 parts, you can reduce it down to 4 parts, they start to listen. Yeah. And I think that's important, and you can't do that without showing and see something work. The bike is like seeing is believing, I'd say.
Interesting. Yeah, I mean, certainly with your vehicle, right? I think the Stilride one is, we've had it in the newsletter before. It's always very popular when we featured it. I think people were there was a lot of interest around that first time we featured it. It's just very visually striking. People immediately want to know more about it. I think it's available to it's available to it's under like pre-order, or you can reserve now on your website, which I recommend people here who are listening go check it out. It's stilride.com. But it sounds like, based on what you just said a moment ago, the business is also a little more B2B oriented around helping other manufacturers sort of figure this out. So in many ways, Stilride 1 is an amazing vehicle, but in many ways also a proof of concept to show people this is what the technology, this is what our processes are capable of. And so Stilride is also exploring other avenues of potentially go-to-market and things like that. Is that right?
Yeah, see, I mean, we will not be a manufacturer of motorcycles. We will make Stilride 1 is a golden egg that we have, and we will produce it, but we will make like small collections of it, and keep it quite, it's a brand builder, it's a brand communicator, but the technology itself, which is called Steel Fold, the technology itself, it creates a value of reduction of components. You can have high strengths, etc. So what we see ourselves is like an ingredient brand, pretty much like Gore-Tex. They put a value into a piece of clothes.
Yep.
It breathes, but it's water resistance, waterproof, and the same thing with our technology. It brings value into it, and I think it's the value itself is that we can manufacture with a much smaller environmental footprint, and a value if you take it to the bike, for example, that we make a very, very stiff chassis, a strong chassis that is excellent, riding experience. So yeah, an ingredient brand that can empower, already existing, brands, or empowering new designs, I'd say.
Got it. So the secret sauce, is really the folded steel, I think I've seen it referred to in the videos as metal origami, which I think is a very nice turn of phrase, and people can really understand and relate to that. What if that's sort of been the core IP of the business? What are some of the technologies you've used and solutions you've used across your development life cycles? What are the digital tools, technologies that are in play for you as you develop this? How long did it take to develop? I'd just be curious to learn a little bit more about how did this self come about?
Yeah, since we started from zero, it started off very much like trial and error. Your insights from doing something you put into CAD models, and then your CAD models, you can analyze them, and then you can start to make CAD programs around them and understand what happens. So we know that this is very much a geometry exercise, and geometry is just mathematics visualized. That's one part of the source, pretty much. Next thing is the material itself. Whether you have everything that's foldable, it doesn't go for steel only, it can go for anything that's foldable. so the material itself, that's what the next part of the source, so to say. And the third one is in what order you make this, you know. And I like to describe it as, imagine you're cleaning your window, you know, and you can clean your window from top to bottom, or from bottom to top. And if you start from top to bottom, you know, you will clean it and it would be dry, you know. But if you do the opposite way, it would start the water will pour, you know, over your cleaned area, already cleaned area. Why do I say that? It's because, you know, it depends upon if you start from one side to fold, or if you start from the other side, you know. So the tempos, and in what order you do them as well, is also part of the source. So 3 parts, you know: geometry, material, and tempos. I don't know whether I answered your question, but then, so we kind of understood that, and we created our own software around that, and our own hardware, you know. And when you're out on a new journey with someone hasn't been, you know, exploring before, you have to prove yourself, and you have to, you know, it's very much about proving. But then at the same time, it's very nice, coming from the automotive industry, you know, working with I use Alias, you know, as a professional designer, and when working with cars and motorcycles, and it's very nice to have something that you can depend upon, you know. So when it comes to other things that we know that we have to craft and shape, then you pick up the Thor's hammer for design, which is Alias, I think. Yeah.
Well, you made the Nordic reference first, so I'll feel bad not making this, but it's almost like I've seen you guys compared to almost like an IKEA of design, right? And revolutionizing a manufacturer. I mean, what IKEA do with flat packing is obviously quite different, but taking a very manufacturing centric approach to rethinking product, I think it's sort of a really interesting tradition which you guys inhabit. So I think it's very cool that you've been on this journey for as long as you've been on it, and it's evolved and grown from, you know, being something that I think was originally focused much more in the moto and micro segment, and now being something that can be applied across auto and different roads as well. So I think it's really great. I guess that kind of invariably leads me to the question of, you know, what comes next for you guys? Where you go? What's the future look like for Stilride?
Next thing for us is, I mean, you just talk about the bike itself. We can do a trick that no one else can do. Really, we can change the material, and we like to explore other materials, you know, onto the very shape itself. We also have textures. We have treatments, material treatments that we want to try on the bike. But then, I mean, the journey has just started with the other manufacturing, with the steel fold side of the business. So we managed to do, you know, car doors from, you know, one part. We can do. We very much work with the automotive industry. That's an area which is very much interesting, but we also, that's not the only focus we have. We also focus on other things, and I think structural wise, one very interesting product, or maybe wrong to say product, but it's more as a project that we've been doing. It's about a wind turbine foundation, and it's out there on the internet. So if you do wind turbine Stilride or wind turbine steel fold, you can see it. But I can just, you know, since going back to saying these 3 pillars, you have for our technology being geometry, materials, and tempos. Geometry works in micro and macro. And the case with the foundation for a wind turbine, we're talking about the foundation 30 meters long, and yeah, I think the interesting thing there is that we created the foundation very much like inspired of a tree. So instead of having a gigantic foundations of cement or concrete, we could reduce, we could just eliminate the concrete out of the equation and make a much more sustainable construction in the end. But it's all out there, you can see it.
Yeah, I just shared. It's a cool case study. I just shared a link
Yeah.
with the group so they can look at it too. Okay, and then one more question, I guess, would be, you know, there's so many startups in our community. There's so many companies undergoing a similar journey to I think you guys have undergone, which is, you know, trying to basically come in and build a product or develop a new technology from scratch, which is certainly not easy. I guess my question would be, you know, for anyone who's on this call, what is your one piece of advice to give to companies that are either starting out on this journey or in a similar place where you guys are now and sort of be the
Yeah, look, I'm losing you a bit, but I think you wanted me to give some advice on how to when thinking about startups and micromobility. I'd say if you want to do that, yeah, I think start off, you know, understanding what kind of vehicle you would like to do, you know, and make your research. It's like everything, you make your research, you know, very, very thorough. And then also, if you have an idea, you can always buy a bike and have it as a donor, and then you can tinker from there before you start to trying to reinvent the wheel again. You know, I'd say get your hands dirty and just go there and tinker and do that. That's would be my what do you say? That would be my insight on for micromobility startups.
Great.
If you,
okay. We've got a lot of audience questions coming in, so I want to make sure we have time for those. And so let's jump right into them. One question which came up right away, which surprised we didn't talk about more actually, is sustainability. So, you know, one of the questions here came in, I believe it's an anonymous question. It says, I like the steel folding idea. Hydroformed aluminum is one of the highest emitting production techniques, making aluminum bikes less sustainable. I'm curious, how much did sustainability factor into your decision making around folded steel?
all right, again, I'm losing you a bit, Luke, but are we talking about aluminum sheets, and are we talking about how much you can save, or how you can reduce the environmental impact, or?
Yeah.
All right, okay, of course, it's everything starts from a flat sheet, you know. So of course, from the beginning, it's just to make your design, so it's foldable, and then I'd say then you can nest your design on a flat sheet, you know. So you make it as to avoid any excess material, and you can always also, if you have a lot of excess material, you can always put other things in there, or you can laser weld things together and then fold. So you can make it you can utilize your flat sheet, and then it's just a matter of, you know, trying to reduce material. So that's one thing. The other one is to make integration design. And what's that? Integration design, it's something that's used very much in flat sheet metal folding. There are like combination tools where you can make threads directly into the sheet metal itself, and this is something that we can use as well. Imagine you would do that and then traditionally press your design, then you would destroy the threads, etc., and these components. But this is something that we do a lot. So then we can make rid of a lot of components. So we reduce the boom list, which is the bill of material. So that's also something that we just calculate in the number of parts, really. So that all comes together in the equation of reducing environmental impact.
Great, and I'm hopeful my audio is better now. Is it any improved?
Much better.
Great. It was the headphones. Okay. Another question, a very specific question, but this is what we're here for. Carl asks, what gauge steel are you using for your sheet metal?
We can use, I mean, we use cold roll, hot roll. We can use stainless steel. We've done spring steel. The thing what's really, really interesting is that we can perform folds with very high strength steel. So we folded like 1500 megapascal steels, you know, steels that doesn't like to be shaped. And why? Because we have an incremental folding procedure. Used aluminium as well, copper. What have we fold? Galvanized. We even perform folds with sandwich material. When you use mono material sandwich, which is like, imagine you have aluminium and then you have an aluminium foam, and yeah, so which is very, very interesting because sandwiches, but they don't like to be folded. So yeah,
That's a
still
quick
exploring that.
Another quick, and this is the same questioner, follow-up question, also kind of specific, but again, I think they're here for it in some ways.
Yeah.
Is the tooling you use to fold reconfigurable, or do you make a new jig for every part?
So the folding procedure itself is performed with a device, which is a roll folding device that we used to describe as a combination of a sewing machine, and a can opener, pretty much. It's so and an English wheel. Yeah, so it's a combination of that, but we can set a different angle, you know, very much, and we can do that. We can adjust that over the design itself, and yeah, when it comes to jigs, just to touch upon that, one of the tricks that we do is that we put together parts pretty much like a jigsaw, you know, and then we weld them together, like laser weld them together, and then we can fold. Because you see, it's so much easier to make things in 2D rather than 3D. If you want to make jigs, you're always in the 3-dimensional, or often in the 3-dimensional space, which you have to fine tune your jigs, etc. So we're taking the number of jigs down to a minimum. But ultimately, of course, sometimes you need a jig. So if you want to produce them for the bike itself, we have a jig. Yes, it's made out of 9 parts. So we need those jigs, especially when it comes to things like the steering axle needs to be very much in line with the rest, you know, so the wheels has to be in line. So yes, jigs are needed then.
Cool. I actually have one final question, maybe to close this out, and this is for you, Rohit. I'm just kind of curious. You know, Autodesk, you know, is a partner to just a plethora of different kinds of manufacturers and companies, right? I think I saw NASA in your video. I saw Rivian. I saw, you know, and not just in the transportation and automotive space, right? But all kinds. I'm kind of curious from your privileged viewpoint, where you can kind of view into all these different companies and industries. What are some of the unique challenges faced by micromobility companies specifically as it comes to product development? Are there different challenges than other sectors, you know, other sectors of transportation?
So yeah, Tua might be able to give a perspective on this shortly after, but one of the main things that we see with a lot of startups is that resources finite generally, right? So effectively, you might have in a traditional organization, you go to the design department, there might be 50, 100, 200, depending on how big the organization in terms of people. Whereas in a startup, it might be a person or half a person or a quarter of a person's time. So effectively, one of the things that we've seen is actually trying to equip people with the right capabilities across the entire life cycle, in order for them to get something out the door, right? And it's hence why we've got so much focus on the platform, and for people to be able to collaborate, share data, make that data easily usable, because you effectively just need enough capability to be dangerous to bring something to market. With just 2 minutes left, I'll let Tua answer from a real life perspective and having both be in both sides of the camp, but I don't know if that's what you're seeing as well.
Well, I mean, I think I go back to my answer before. It's just like you have something that a tool that you trust. It's very nice to have, yeah, it's more about feeling the control of the tools and what you need to perform. So from my point of view as a designer, that's the most important thing. So because everything happens on the screen and you see that your reflections are not working or whatever, and then you need to adjust that and you need to alter that, and then you can depend upon your tool, and then it's such a relief when you get everything right and just like crisp. Yeah.
Great. Well, I know we're coming up on time, and that feels like a good place to wrap it potentially. This has been a really great conversation. I love when we can bring together technology leaders, designers, people who are building the solutions, people who are implementing the solutions, because that two-sidedness of the conversation just really helps, shed light on what the process of product development is really like. I guess from my perspective, I would love to leave the audience with a little bit of a sense of where they can find you guys. I'm sure people will want to reach out. Maybe two of you first, and then Rohit, what's the best way people to get in touch if they have extra questions?
I'd say you always have LinkedIn, of course, but then we have our homepage, webpage, which is now Stilfold or Stilride. It doesn't really matter because we're in the transition. We're going from Stilride, which is the product, but Stilfold is the technique, So find us on stilfold.com, and then you can reach out there, to us, if you have any questions. More than welcome to write to us.
Perfect. Rohit?
Yeah, so the same for me. If you want to have a quick catch up or a chat or a virtual coffee or something, LinkedIn's fine. Happy for people to reach out. But then obviously, please have a look at the Autodesk website if there's something specific that we've spoken about today that has sparked your interest. And then if you do need to get in contact further, there's ways of doing it through the website. Or yeah, happy for you to come and pick me, and then happy to put you in touch with the right person, really.
Perfect. And the last but not least, now we're a little over time. Autodesk has been kind enough to make a ebook available for us about the topics we've discussed today, about the digital transformation in manufacturing and micromobility specifically. This is not something that's publicly available. They're doing it just for folks who are here today. So it's cool to have the exclusive on that. If you guys are interested in learning more and seeing that ebook, send us an email. You can email me directly, actually, luke@micromobility.io. I'll make sure you get to the right people. It's a great way to continue learning about some of the topics we talked about today. Cool. Rohit, Tua, thank you so much for being here. Really appreciate your time. Really appreciate your insights. This was a great conversation. Looking forward to chatting more soon. Hopefully seeing you at one of our conferences soon. Any other questions, please feel free to reach out at the email addresses we provided. And thanks everyone for being here.
Thanks, Luke. Thanks for having us.
Bye, everyone. Have a great day.
Bye.
Bye.